1, 2, yeah. Hi, everyone. Yeah, really nice to see you here. A lot of people. Yeah, so I'm Kunichik, and I'm thrilled being here on CppNorth. Today I'll show you how to bridge C++ and Java on Android, and I will be sharing my experience of building a real humanitarian project, detecting landmines using mobile phones. So I'm a software developer at PokerStars and recently completed my PhD at Taras Shevchenko National University of Kyiv under Professor Vasil Tereshchenko, and today's talk builds on that research. But before diving into the technical details, let me show you why this matters. Because sometimes the best code we write is the code that saves lives. So this is Ukraine, the country contaminated by landmines, 17 million of explosive objects. And farmers can farm, children can play. Yeah. This is humanitarian crisis could be for decades if we don't apply technologies. So during my PhD, I developed computer vision models for landmine detection, but models itself doesn't save lives. So we needed data from professional deminers, photos and actual explosive devices, and classification details. This data is crucial for training AI models. But here's the challenge. This kind of data isn't just handed out for free, so we have to offer something, bring something on the table. So we developed a mobile app, so myself developed an app with cloud-based detection of landmines. It's actually a screenshot. It's pretty simple. It should be pretty simple because deminers, they will not read your documentations, manuals. It should be like a button. Everything should be automatically, maybe some really basic settings. And here we got deminers interested. So first it runs across different major platforms: Linux, Windows, Android, and iOS, but iOS under development. And because deminers, they are using different devices in the field. So second, users can review and edit AI predictions. So again, everything very easy, so you can just round the circle and there will be square around the landmine. And also they can change the types of landmines, move it, so edit it anyway. And also we offered sending the data to the server, what we actually needed, so to get data and train our models, retrain them, because there are a lot of different installations of landmines. So we used these HTTPS requests through the cloud, but deminers works usually out on field and there is no internet. There is rarely even cell phones work. So we needed offline inference. We chose Android because Android covers 74% of all mobiles worldwide. So we needed offline inference. The question was how to build. We chose Qt to build across platforms. So the logic stays the UI built on QML. QML, it's a language, Java-like language, declarative language. You can describe whatever you want, make out of the box. There are a lot of components, but you also can create your custom. And it's pretty responsive and fast. So the logic stays in C++, where we can share it across different platforms. And we use Qt concurrent for heavy operations, no frozen AI. And we're using Java for conducting inference. So why not rewrite everything on Java? Simple. We need iOS support too. So C++ core with JNI bridge to Java ONNX. Now let's dive into each layer. So here what we wanted. So 2 lines of code. Simple, right? But if you ever tried Android and C++, you are probably laughing. Yeah, let me show you why. First, let's define JNI. So it's Java native interface. Android's bridge between Java and C++, and vice versa, C++ and Java. So, been there since API level 1, we access it through the Qt JNI object wrapper. So, if you want pure C++, you need also NDK. It's native development kit. But even then, you still need JNI for Android APIs, camera, storage, permissions. Now, you might think, just call ONNX from C++. How hard can it be? Well, let me show you reality. The challenges hit hard. So, build ONNX. ONNX Runtime. It's a library for conducting inference, getting AI predictions. Through it, we can convert different versions of models. So it's too powerful. Yeah. But regarding Android, documentation is sparse. Also, Android's scoped storage. There are privacy features that restricts file access. And you can just save files anywhere anymore, since 10th version. And moving 2 megabytes images between C++ and Java, that's where our performance dies. So here are our architecture questions. How we can connect C++ with Qt and conduct their AI inference. So I spent a lot of time, maybe 1 month. So I tried to build everything on ONNX. I built it from source. The documentation was outdated, fought with CMake configurations. When it finally compiled, the APK was 50 megabytes more and larger, and it crashed on certain devices. I couldn't find out what the issue, because my audience which were testing, they're far away. And I made a pragmatic choice, so use Java for inference with ONNX. So it's 30 minutes of working, and not much difference between performance. So, but it's on pretty good device. On different devices, it could be significantly different. It could be seconds on low-level devices, and on faster it like this. Because some devices, they have Android 7 plus, so it's pretty old. So let's check what the difference between conducting inference with Java ONNX and C++ ONNX. So the main thing, it's very long time for deliver. So if you want something, it's very slow. But my project, it developed very rapidly, so I contacted suppers. They wanted something. I couldn't give them something which doesn't work. So, but still, I use Qt. It provides really nice wrappers for working with JNI. And Qt JNI object handles the complexity, method signature, reference counting, types conversion, much cleaner than with raw JNI. So here, 3 trade-offs. The first one is write everything with C++. So ONNX, which is originally C++ library. Then like intermediate decision to use runtime Java, but raw JNI. And the third one, which I came with, it use runtime Java and Qt JNI. The real challenges, so we have to marshal, so we send between layers, we have to send about 2 megabytes images. And our performance was about 1 second, so it's what we wanted for inference. Memory constraint on cheap devices, we had a lot of cheap devices, so suppers usually have not fancy phones. Threat safety across languages also hit us. And let's take it one by one. But first, let's start with basics. How do you actually call Java from C++? I'll show you Qt approach first, and then I'll show you quickly how it would be if we use raw JNI. Let's start with the Qt JNI object. So it's nice wrapper, which does everything under the hood. Reference counting, life cycle management, so everything there. They have very sophisticated constructors, so it works everything for you. And it's much nicer than working with raw JNI. And also we have such calls. So I'll explain them later, but they look like this. So first we have to have activity from Qt, or from Android. It's just name of the class. Then we call the method, and the last line, it's parameter. I explain it later. It's signature of the function. So, as I said, this is class name. Notice that there are no dots, only slashes, except for dots. Then activity is the name of the method, and this is signature, so parentheses, there is no parameters, and after this, the object which the function returns, the object activity. Notice the difference. So first, we call static functions, or call static object method. We send the class, and then on it we call the activity. And then we call on the instance of the class, we already call object method. All right, so let's return to previous calls. So we got activity, we got context, we send it later, and we actually can finally call our function. Again, here they repeat what each line means, but we can call function internet connection checker. So it's needed for check what the connectivity kind of connection we have to decide whether we have to say data or no. So activity is short-lived, so we cannot reuse it, but context we can cache it somewhere and reuse it call after the call. Pay attention to this difference. So we have call static object method, call static method, call object method. So there are more. So, but Qt wrapped them with nice templates. You just need to specify which kind of return value you are expecting. So if it's primitive types, you use template parameter. If it's kind of object, any object, you always use corresponding object method, either static or no. But what without raw JNI? I told you that I'll show you it. So here's 60 lines of boilerplate. Let me scroll it. So it does pretty much the same what we done before, just for call the same connection checker, internet connection checker. But there are a lot of stuff. You find class, get method ID, handle errors, manage references. So that's why we are using our wrappers. But these signatures from previous slides, they were a little bit cryptic, right? So how to compose them. So never write JNI signatures by yourself. Here are some Java methods. So you could guess and debug crashes for hours, maybe for days. But you can also use Java P. It's like console application. You can just run it and have all the needed strings. You just copy them to the code. So everything easy. So enough theory. Let's see how all this works in our real image processing pipeline. I'm doing it not with pipelines. It's just like the process algorithm. Everything started QML, as I mentioned. User taps capture the image. It saves to some directory. Camera saves it to the cache, and we can wipe it anytime. After that, camera signals us with the path, note the location, up cache directory. This is temporary. And Qt loads the image, very size 640 by 640, our model's input path. Doing this in C++ before passing to Java, saves memory, and then on JNI boundary we have less payload. So, but we have to save our image permanently somewhere. So we call Java methods, pass the data there, and save it in the Android Media Store. So Java uses Media Store. It's Android official API since Android 10. Image goes to gallery, survives and install, visible to users. Here we can see the path transformation. So we have some temporary path, and after that we saved it in Media Store, and user can open it. Back to KML. So here we clean up the code, delete temporary file, and looks like complex, right? But it handles all Android storage rules correctly. After that, we clean it asynchronously with use concurrent, and continue to Java. We send our already new image path from Media Store to process. Now the fun part. Android packs ARGB into one integer. Shift bits, mask with 0FF, normalize between 0 and 1. Alpha is usually 255 for photos, so no transparency. And then, where the things get tricky. So Android stores HWC, so height with channels. Each pixel has RGB together. ONNX wants in different order, CHW. So all reds, all greens, all blues. This mismatch means we can't just pass the data. We need a complete reorganization. So this is how Android sees it. It's like the picture with 9 pixels, and like in real images. And let me play it again. And come on, yeah. And we reorganize them to the different order. So this is complete reorganization, about 1.2 million of values. After that, we also add some one dimension, copy everything one more time to the new array, and everything ready for inference. But how many copies have we made? Yeah, since we captured, and yeah, more. So we captured, let's recap. So we captured, we cropped, and so on, yeah? So it's a lot, but it works on 19,000 devices, according to Android Android Store. So it works, and each step it handles concrete question. So, but maybe I can save somewhere here. Can you check where I can not make a copy? For example, here, when we already saved it in Media Store, right? So we cannot open it in C++, but pass the path straight to Java. So this is what I just noticed when I were preparing to this talk, so I want to implement it later. Okay, so it's actually the inference. Just call ONNX runtime session, or ORT, it means ONNX runtime session, and we have results. So we spent 20 slides on the data marshalling, but actual AI inference only one. So it's the world of machine learning, 90% of plumbing. One more thing that we have reorganized the data back because we have certain input. We have to change the indexes, make it from 3D array to 2D, to have like more intuitive view for it. But here actually we usually have, for this kind of model, it's YOLO, we have about from 1,000 candidates usually, and we have to filter them, apply several optimizations, compare with threshold, etc. So after that we have some results, usually not much. And here our pipeline. So not pretty, but hence all edge cases, and it doesn't crash on different devices. So lessons we learned hard way. Can fight this platform. Multiple copies are inevitable, but it works. That what matters. Document the weirdness for future you, but it's usually not true. Now let's look at the problems we face along the way. But first of all, let me introduce the local references. Local reference is not an object, it's a table entry. Points to the Java object, prevents garbage collection, and gives C++ access. Think of it like it handles in C++, it's C. The reference isn't the file, it's your access ticket. Close the handle, file still exists. Delete the reference, Java object still lives. But it could be deleted also anytime. All right, so step one. C++ create Java byte array in JNI and passes it to Java. Method save image gallery. Step two. Java code stores it in static field. Last image is here. And calls delete local reference after this. So after this point, we already don't have control from C++. It lives in Java. So delete local ref removes only the local reference table entry. The actual byte array object lives in Java heap, and garbage collector takes care of it. So manual delete local ref is complex. So it's easy to forget about it. Miss one leak, exception thrown leak, each return leak. But we have push local frame, pop local frame. Instead of tracking every reference manually, create a frame, work. You can create as many variables as you want, but you have to specify the maximum amount. It's 20. And when you go out to this line, everything will be deleted. And here's the question, what's wrong with this code? So what could be happen when you create byte array? So it's created on Java heap. So here we create array on Java heap and return it here.
So that's a basically on
So first of all, we create the Java array, and then this local entries table, it has only 512 slots. So when we iterate it 1,000 times, so we have overflow of this reference table. So it's JNI table. So Java is okay, so Java has a lot of memory, but JNI has this limitation. So that's why each time when we do not need this array, we have to clean it. Yeah, so we have crash. And then the fix is simple, just add delete local ref and free the table slot. Here another issue, so the same line but without loop. What the issue could be here? We can call it from outside, right? So yeah, here in our function, maybe we call it once. But if we call it like in previous way in the loop, so the same could be here. So that's why always call delete local ref, and you will be saved from the hard debugging because it's not easy. And there were some already issues on Stack Overflow, and Android community, they share some tips how to work. There are more than I discussed today, so keep them. But manual cleanup is a role problem. So one exception, memory leak. The C++ way, so RAYY, so resource acquisition initialization, and it's when you acquire resources in a constructor, release them in a corresponding destructor. This wrapper holds the array and its JNI environment, and when it goes out of scope, the destructor runs delete local ref automatically. So no manual cleanup needed, and we use it like this. We just declare variable, already put into it the data, and when it goes out of the scope, use them, and then goes out of the scope, it deletes. So 4 golden rules. Delete local ref and loops, always use push local frame, pop local frame, wrap references RAII when possible, never rely on garbage collecting. So here the threading landmark. So create reference in my thread and use them in another. It's crash because local references, they are thread local. That byte array valid only in the thread that created it. Pass it to Qt concurrent, you are passing already that pointer. So undefined behavior, the best which we have. So the decision, we can keep everything, so all JNI work related from the creating the data, calling the method, use it. If we use wrapper like here, yeah, everything will be deleted automatically. So, and when environment destruct, it will detach from the process. But usually we have a program, we have not so many classes, for example. I don't know, 1000. And each time when we call in them, each time we are using this mechanism, and each time when we create a connection to Java, it attached to the process. It's not the fast process, so it's better to use some local mechanism. So in this example, I'm using Qt write block to ensure thread safe access and exclusive modification, and so this shared cache. So here we create cache, make global variables, and then use them. But look closer at this line. So we have new global ref, so something new. Because you might wondering how to share the variables between threads. These references live forever unless explicitly deleted. Use them wisely. Once cached, they still until update. And look at these lines carefully. Find class returns a local reference, and then new global ref creates a global one. But where is delete local ref for the original? Because On Java side, we have two roots elements for the same data, and they will not be deleted. And if global ref will leave whatever till the end of the program, but this one will leak. So we have global references and local references. Local references live in thread local storage, limited to 512 slots per thread. They are auto-deleted when your JNI method returns. Global references live in JNI's global table. No hard limit, but still right. The next tip which I want to share, so here how to call Java, and usually Java throws, when it throws exceptions, they just silently suppressed. So your app keeps running with wrong data, and always check for exceptions after JNI calls, one line of defense against silent issues. But error handling in JNI be also strategic, so not paranoid. Look at Qt's own code. So sometimes they check something, for example, new byte arrays rarely fail, only when it's really out of the memory, and it's usually safe. But method calls to your Java code, network operations, it's better to check them. And the same delete local reference usually not needed. Now let's talk about performance. So what happens when your process runs hundreds of times? So look at this naive approach. So we can create thread attached from Java machine, because how it works, each thread which is created, it attaches to Java machine by itself. And we have to, each time when we call this lambda, we are attach, detach, and repeat it for each image. So that's expensive. And we can use thread pool. In this example, I'm using Qt thread pool. It does everything for you. Threads attach once and stay attached. The pool reuse threads, so no constant attach-detach processes. Submit task, let the pool manage threads. Each thread attaches JVM and first use and state attached. But sometimes the smartest move is to avoid the problem entirely. Let Java handle its own threading. So one JNI call and Java's executed service takes over. So we can just send all the paths we have, and Java will create all the needed threads, so do everything you want there. But be careful with async calls, returning something to C++. It's very tricky. Just be careful. Let's go to issues which we had. First of them is camera. Camera and other permissions. Camera storage, etc. So here the code, it looks fine but doesn't work. If we want to save data straight to some path, we will fail, and usually all this will be suppressed. So there is no permissions. What we should do, so we have to check permissions. Check if we have access to camera. If no, it's denied, we can request. And if we are okay, so after that we can run the method. But we also can have some helpers. Just write corresponding helpers for each operation, for each set of permissions. So I usually have like one function which calls all the permissions, and there are some permissions. And what the interesting version of the version, Android, when it updates, they can change something. They can change everything dramatically. So you can just, it could be completely different, and also you can change also a manifest. So each update is really hard. Okay, so one more Android headache. Where can you write files? So try standard path. So you can guess, like this one, maybe another one, because Qt, it gives some some convenient functions for getting the path, but they are not working usually, because each device has its own specifics, and there are many workarounds. One of them, for example, save the file, then reboot the phone, and after that your file will be appeared in your other programs. You can show it, you can send it, or just save it and then send some broadcast, but it doesn't work. One more Android headache. Android data storage creates a lot of headaches. So you can just write files anywhere anymore from 10th version. And that's why, by the way, because I'm supporting older versions and new versions, so I'm using an old approach and this one. Old approach, just write to the directory. New one, you have to communicate with Java Media Store. So the solutions ask Java to correct path. So you just ask it, which the correct path for my pictures. It gives it to you and you use it. Just create some thin wrappers around, and after that use it. You will use it in different places. So let me show you optimization journey. So started at 4 seconds per image. First win, we discovered that bitmap create scale bitmap was creating multiple bitmaps, copied values into intermediate bitmaps. So we created direct scaling and saved 400 milliseconds. Adding Qt concurrent usage, it saved a lot of time, so I sent some deleting, I showed it, also thumbnails, also creating them when processing already some images. So finally, I have 2.1 line per image, like in medium devices. But what we can use in the future, what I also discovered recently, we can reuse tensor. You remember before conducting inference, there was prepared tensor. We can reuse it. And also batch processing. And, for example, if we open a lot of images, 4 or 5, we can process them on a batch. Now, this architecture isn't just for landmines. Any visual detection, visual inspection task where you need on-device AI can use these patterns. Manufacturing quality control, same architecture. Medical images on portable devices, same patterns. The key insight is that JNI, despite the quirks, it really gives you access to Android infrastructure, ecosystem. You can easily communicate with it, and you will be only dependent from changes on Android side, because usually how the change it goes. Android changed something, but Qt still doesn't. So, but you doesn't know. You don't know. You start to fight with the issue. You tried everything, and then it just the last one you decide, oh, can I update Qt? And they already fix it. But before that, you can spend, I remember I spent my vacation, almost all my vacation debugging the code. And just in the end, I updated it in Mexico. Yeah. So let's wrap up with key takeaways. First, Qt JNI wrapper makes Android integration possible from C++. It's not perfect, but it works. Second, how you marshal data between language matters more than your algorithm optimization. So first, think about that, how you work with the data. Third, Qt concurrent is your friend, or any other what you are working with. And it makes concurrent processing almost trivial. And finally, real-world AI often needs hybrid architecture. So pure C++ really works, or pure Java really works, so we can combine. So all the code will be allowed accessible on the GitHub, but as we have a little bit time, I can show you some bonuses. Yeah, so here how the signatures looks like. So usually we have some parentheses. It's the parameters. Inside one letter, it's the type. It's primitive type. If it's something bigger, it's usually either array or some objects. And objects need not usually, they must be surrounded by letter L and semicolon at the end. And there is mapping of the type. So QString needs UTF-8 conversion. QImage doesn't map directly, so we encode it UTF first. It adds overhead, but ensures compatibility. PyJPEG, so it's universal format. Java always supports it. It's compressed, smaller to transfer across JNI. No endian issues, and so on. Here what I told you about how JNI handles each call. So under the hood, there are really a bunch of methods which have name of the type in the method. So if we need integer returns, we have call static int method. If we need bool, call static bool method, etc. So for all the types, there are about 30 methods. So if you work with this stuff, you can just implement your own all convenient helpers. Under the hood, it works interesting patterns like template with macro. Yeah, it works pretty well. So when we send the name of the type, we just put it into the name of the call function and calls. And vice versa, we use different trick for primitive types. They usually have size of 2, like now terminated symbols. If it's array, it has square bracket, and then that. And if we have string or another object, we have, as I mentioned, L, and then the name of the type. So it works like this. So if we have size of 2, it's like primitive type. If it has first square bracket and size more than 2, it looks like maybe not optimal, but it works in compile time. So why not? Maybe I would implement some constants, context. Yeah. And yeah, that's it for today. Special thanks for my team. Yeah. They really helped me to improve this speech. And special thanks to our manager Maria. So she allowed me to steal all the team. All these guys were sitting, were discussing, reiterating, and after that, believe me, it became more ingestible. So let's connect with my contacts. But if you want, I can show you how it works. Yeah? Do you want? Well, let me click. Is it clickable? Yeah. So the first there was like some under the hood work. After that, I just opened some files, shows anything. It works pretty fast. By the way, this phone is about 7 years old. So now I'm opening another one. And here we see that it's working about maybe 1 second, 96% of 96% inference probability, and so on. And another question, another video. Yeah, this one is already finished. Another video. So here I opened the file, so it works pretty fast. I still continue. So I can edit the results, move the frame, everything like this finger. Choose another object, again open it, and another video. Yeah, So another video. Here I already making photos. I told you that it's old device, so remember how many copies I'm doing under the hood, so about 5 copies. So here it maybe 4 seconds instead of 2.1, which I had on more modern devices. This one is Chinese device, I brought it from Ukraine. But it's also, so it was yesterday. I just played the object. I 3D printed them. It also was not easy task to 3D print them. Now thinking about 3-4 seconds, 70% of probability. So now what I'm doing here, most probably I change it. Yeah, I'm drawing around, can adjust it. So it's pretty simple. So for end user, it could be really simple because they're very people under high stress. You cannot say them. Here the documentation, you can read it. If you have question, no, like straightforward. Make a photo. Usually I even don't forward them to edit. Just make a photo and send. I need that data. I will take care of it. Yeah. And now it's already, yeah, now I'm done. Thank you so much. It was really private talk. Any questions?
So I will have like a comment and a question. I'm coming from like a Java background and not necessarily a C++ background. And yeah, I remember when I did like a Android dev, I would always see random logcats of like a JNI. I've always wondered, oh, what is that? What is Qt? What's JNI? So yeah, this is pretty eye-opening as to like a background look of what's actually happening on like Android logcat. But I also want to ask, it's like, is this like, how do you, are you calling it like straight from, are you building like a UI from a Java and calling JNI, or is it like the whole thing is like in C with like some Java like calls like back and forth? I'm kind of confused on that.
Yeah, so I have some code, so it's just directly the project, and there are some helpers, and each time when I make the photo, yeah, when I capture. So here, for example, I need the permissions. First time, I send the Java, call some helpers. So then I make a photo. I have to save it somewhere because users can open it afterwards to share it. And each time I call in Java. Of course, it's because it was MVP. I have to develop it very rapidly. So that's why I think that all of you notice some bad stuff, yeah, so which could be improved. But what the nice part of all of this project, it's really, I deliver it very fast. And it was when I'm working in my ordinary job, but I have to do like this project, so I didn't have much time to think about optimization. And people on the field, they also don't care. So they don't tell me, oh, my inference was 2 seconds, look at this work. Oh, they usually, sometimes they just turn it off without it. Yeah. But actually JNI, it's working mainly for talking to Java, or to C++ from Java. And by the way, this stuff is delete local ref. If you call C++ from Java, JNI, it guarantees that all the stuff will be cleaned up. But vice versa, it doesn't work. So it's like, it would be, but there is no direct like sentence. But vice versa, they say that if you call from Java, as soon as you return back to the caller, so everything deleted. But vice versa, it doesn't work. Did I answer your question? Or comment?
I think I'm starting. Yeah, I think I'm starting to get it then. It's like you have a Java app, but some functions like you call JNI to those functions, right?
I have C++ now, so it.
The whole app is in C++.
Yes,
Okay.
So all this, it's written in QML. It's Qt.
QML. Yeah, QML.
QML is JavaScript-like language.
Okay.
You model it. It's like first layer. Qt uses signal slot mechanism to send the data from a main loop to corresponding, they call it slots. So each method which you call, they connect it in certain way. Yeah, so each time you from QML you use all the logic written in C++. It works on Linux, it works on desktop. What was the first? So I wrote it in desktop and then started to think, should I rewrite everything on Java? But I need an iOS, right? So then I have to. So I decided to keep everything on one place.
Okay, yeah, I get it. Yeah.
Okay, yeah, maybe I have to open it.
Hello, great talk. How did the process of training models looked? What did you use and how did you gather data? So now the app is like released, right? So it's just used. How did you train it during production?
I have some MLOps pipeline, so on Google Cloud. Under the hood, the model is the YOLO model. So that's why, by the way, all this pre-processing, it's like YOLO dependent. Because YOLO expects, gives, post-processing gives a lot of pictures, a lot of detection. If you use in other models, there will be different. But you can just write interface and implement for different models, use them depending on the model which you are using. So in the future, I'm implementing. Yeah, so it's YOLO. Nothing fancy, but sometimes I can train for 10 days, for example. Yeah. Anyone?
This is going outside of C++ and Java for a little bit. So the landmine detection is purely optical, correct? Are there any planned enhancements for integration with other detection methods or other things? Like, for example, you can do kind of out of visible light photography in order to make plants show up bright red as opposed to bright green. And I imagine that green landmines would continue to show up as dark colors under such scenarios. Or is the limitation in terms of what the hardware has to run something that prevents the integration of additional technologies from being used?
That's a good question. So there is no restriction on model. The data, here it's like my initial data, but when I trained the model, you see it was like under some. So I tried to modify them. When I conducted the experiment, I went to the field, used some grass, etc. And also I have a bunch of augmentation methods. So the model, it's covers. So actually after the training process, it recognized these ones, they recognize like perfectly, 98, 99%. But as soon as you go to the real field, there are about 20% of difference, about 80%. So that's why I came up with this app, because I needed this data, but nobody can offer me. And and I found some sappers, and they helped me, but I sent them how to easily send it. And in the future, I want to use different methods, because this one, it works perfectly fine with some most famous landmines, but there are already more than 1,000 of them. So, and there should be different types of ML, for example, anomaly detection. So, like, hey, something there in the field, something unusual. What it is? And you just sketch it. There are ensembles of models, and go to another one, another model, which already classified. Yeah. So. Okay, I answered the question. Thank you.
Great talk. Thank you. Thanks for being here. Do you accept any donations to help you continue your work?
I didn't ask about that, but yeah. Yeah. Yeah, actually it was pretty limited. That's why I didn't, maybe in private talk I can tell you all the methods that I used for conducting this research, but it was pretty difficult because I conducted my studies in Ukraine, so International International University. But when war started, I escaped here, and it was pretty difficult. So it was like cold call. So I knew a lot of guys from armed forces, but not sappers. So I asked my friend asked another friend, that friend asked another friend, and this was the fourth guy who helped me. His name Artur. So he told me how it works, because when you don't know it, it's completely like different stuff. You cannot realize. You think, oh, it's some landmine, you can make a photo, but there are a lot of factors which affect because these models have to work later on some devices, some drones or some robots. And there are a lot of moments. Yeah. That's it.